Okay, so this is going to build off of what we did yesterday. So yesterday's stuff, if you remember, we did those trig functions or trigish trigonometric functions, where it was like sine, cosine, and tangent were the ones we were working on. Where we had like our triangles, and then in one where we were using sine of some angle or whatever, that was always equal to, and then you remember the SOHCAHTOA from yesterday, where the sine one was always equal to the opposite side over the hypotenuse. The cosine of the angle was always equal to the adjacent over the hypotenuse, and then the tangent of the angle was always equal to the opposite side over the adjacent. So the same thing's going to apply to stuff we're working on today, so we'll still use that SOHCAHTOA stuff. But now what we're going to do is, instead of finding a missing side, we're going to find a missing angle. So there's one extra step we have to do when we find a missing angle. It's called an inverse of it. So inverse is just like the opposite of something, or how you undo something. Like, what's the inverse of addition? Subtraction, right? So same with this stuff. The inverse of a sine function is sine, and then it's not really to the power of -1. That's just the symbol they use for inverse. So on your calculator, there's going to be one that's like sine to the power of -1, but again, that's just the symbol for inverse. So sometimes they'll call that inverse sine or inverse cosine. They might also reference it as like arc sine, arc cosine, or arc tangent. Those all just mean the inverse of it. And it's basically our way of undoing, if we're solving a problem, undoing a sine, cosine, or a tangent. So like if I look at this first example here, it wants us to find each of these angle measures. Remembering from yesterday, this like kind of circle-y shape with kind of the line going through there, that's the symbol for theta. It's just a Greek letter that we just use as like a variable. So that's just a variable basically. So if we're solving for this theta, we've got sine of theta is equal to -1/2. What we want to do to undo this sine is we want to do the inverse of it. Okay, so to make this sine go away, what we're going to do is we're going to do the inverse. So the sine's going to go away, and we'll be left with theta is equal to, and then you're going to go inverse sine, so the sine with that little power of -1 there, and then you're going to do that to whatever this number is over here. So if it's a fraction, just put that in the parentheses. If it's a decimal, just put that in the parentheses. And then you just use your calculator to do this. So again, remembering from yesterday, you want to make sure your mode is in degrees. I haven't messed with mine, so it's good, but if you did need to mess with it or check it, if you go to the mode button, it should have yours in degrees as the third one down. Radians is something different, so you just want to make sure it's in degrees before you're doing this stuff, which it won't change if you switched it once, but if you're borrowing a calculator or whatever. So then what we want to do is the inverse of these buttons is above all of the buttons. So like you can see above the sine button there, there's sine with that power of -1. To turn that on, you just go second and then hit that sine button. And then you should have something where it says sine, and then it shows like the little inverse thing there. Then you just type in whatever your number is. So our number is -1/2, so -1 divided by 2. Get that number there, hit enter, and it should kick out our numbers. So that'll kick out that our theta is equal to, it's a -30 degrees, which you're like, oh, negative, how does that work? But do you remember when we did like the rotation stuff, and we did some of the numbers were negative and some were positive? Do you remember what it meant when our degree was negative for rotations? Yeah, so this one is clockwise. So negative is clockwise, positive is counterclockwise. That's going to come in more to play, like if you end up getting to trig or whatever, when we do like more unit circle stuff. But if you get anything like that, it's not wrong. You can have the negative degree amount with these. I don't know if the worksheet's going to have anything like that, but I just wanted to make you aware of that. Okay, so then if we've got tangent of theta is equal to 9/13, well, we just do the same exact thing, right? So if I'm getting rid of tangent to get the theta by itself, I would just do the inverse of that tangent to both sides. So the inverse just makes it go away there, so I'm just left with theta. And then if I do the inverse of tangent over here, or arctan, of 9/13, I just do the same thing on my calculator. And I just go, okay, well, I got to go second button to turn the inverse on, hit my tangent button, so I have inverse of tangent. My number there is 9/13, so 9 divided by 13. Hit enter on that. That'll give me a number there, and this one's a decimal one, so we'll just round it. It doesn't tell us to round to, so we can just pick. So let's go 347. Let's do that. So our theta would be approximately 34.7. And again, it would be in degrees because we're trying to find the angle measure. Okay. I'll give you a couple more here. We'll see if I can zoom out and get them all on the same page here. There we go. So those are our last two. So get those sketched out there, and then we'll look at those guys
What are we picking up for reassessing that?
tomorrow. Oh, also, this shouldn't be side, it should be angle. That's a typo there, finding the angle. Okay, so let's take a look at these last couple here. So we're supposed to find the missing angle, so like in this case the theta, in this case the x, and then we're supposed to round to the nearest tenth. Okay, so they don't tell us if it's a sine, cosine, or tangent one. We just have to figure that out on our own. So remembering from yesterday, we always make reference to where our angle is to see what our different things are. So what do you think about like the 4 here? What do you think that would be? That would be opposite, right? Because it's the side that's not touching that angle, and this one here opposite the 90 would be the hypotenuse. So that guy for the 4 has got to be opposite. And then what's the 7 have to be? Adjacent. So if we got opposite and adjacent, are we thinking sine, cosine, or tangent? Tangent, because we got opposite and adjacent, so that would go with the TOA one. So we'd have tangent of, in this case, we don't know what the angle is. So just tangent of theta or x or whatever you're using there. It's equal to, and then it'll be our opposite side over our adjacent side. So our opposite side, oops, I was going to write opposite. Our opposite side is 4, over our adjacent side is the 7, right? And then doesn't this just look like the problems we were just working on? So if we need to get rid of the tangent to get the theta by itself, what should we do? Not that. What did we do up here? When we were trying to get the theta by itself. Yeah, we do the inverse, right? So if I need to get the theta by itself, I got to get rid of the tangent. So I need to do the inverse tangent to each side because that'll make the tangent go away from that. So if I do inverse tangent of that, it gets me down to theta. Then I do inverse tangent over here of the 4 over 7. And then if I just use my calculator there, I would just go second, that tangent button to get the inverse, our fraction there, 4 divided by 7, hit enter. And that should give me that my theta is approximately, what do they want us round to, nearest 10th? So 29.7. And then remembering when we're figuring these out, they're angles. So 29.7 degrees. Okay, and then last one here. So same situation, we got to figure out what information we have based on that angle x. So if that's our angle, what does the 9 have to be? It's the adjacent one because it's next to it, right? So that's adjacent. And then what about the 12? Hypotenuse, right? Because the 90's there, so it's the one directly across from the 90. So the 12's the hypotenuse. So if we've got adjacent and hypotenuse, what function we're using? Cosine, because that would be the cos. So cosine of, in this case, our thing is x, so you can just put an x there, or theta, or whatever you want to do. It's equal to, cosine is the cot one, so it would be adjacent over hypotenuse, so 9 over 12. And then similar to the one we were just doing, to get rid of that cosine, what do you think? Inverse it. So if we do the inverse of that, we got x is equal to, opposite of cosine would be inverse cosine. So inverse cosine of that number there, 9 over 12. And then again, we just use our calculator, so we would go second cosine button for inverse, 9 divided by 12, hit enter, get that our x would be approximately equal to like 41.4-ish. And again, it would be in degrees. And that is it for those. So I'll get you guys a worksheet here.